My name is Josh Farley. I'm a professor of ecological economics at the University of Vermont, and I want to give you a brief introduction to the social and biophysical foundations of the economy. So to begin with, I wanted to start, what is economics? And there's several different definitions, each with their own advantages. I'm going to start with a mainstream definition, which says that economics is the science of the allocation of scarce resources among alternative desirable ends. What I like about this is it presents a series of questions that an economist has to ask and an implicit order for those questions. So the first question, and I think the most important, is what are the desirable ends for an economy? So the definition I gave is, how do we use what we have to create what we want? What do we want? And this is a fundamentally distinguishing factor between different fields of economists. Ecological economists in general say that what we want is an ecologically sustainable system with social justice for all. And this is very different than mainstream economics, which focuses on maximizing the monetary value of goods and services produced by the economy. We maximize their monetary value by selling them to the individuals that have the most money or are willing to pay the most, rather than the individuals with the most need. So a loaf of bread contributes far more to GDP, far more to economic growth when we sell it to an overfed American who is going to throw 40% of it in the garbage than when we sell it to a destitute mother in some impoverished country who's trying to feed her children. Mainstream economists also focus on endless economic growth as a goal in itself. And as we'll describe later, under the biophysical constraints of our economy, that is an impossible goal. So really what distinguishes many different fields of economics is the goals they pursue. And again, just to reiterate, ecological economists pursue socially just sustainability transition. We want to make sure everyone has enough, including other species, which means reducing the impact we have upon our finite planet. Once we know what desirable ends we want to pursue, we need to look at what scarce resources are available. And this raises the question of, what do I mean by scarce? And this also introduces a problem with the definition I gave. Scarce means there is not enough to go around, and use by one person leaves less for others. So we are competing for access to a finite amount of a resource. And this is very obvious in the case of the fossil fuel economy we're currently in. There's not enough oil to meet all our needs, or I should say all our wants. So people compete for oil. If I burn a barrel of oil, you can't. In competition is inherent. You can have private property rights easily to oil. But what we need to do is transition to a renewable energy economy, or I should say a rebuildable energy economy, because we can rebuild the infrastructure required to capture the steady flow of solar energy. So solar energy, we're not competing for it across geographical areas. No matter how much solar energy we capture here in the US, it does not leave less for other people in other countries, no competition. What's required to capture solar energy is knowledge, and knowledge improves through use. So knowledge is not scarce. The more I use, the more a scientist uses existing knowledge, the more new knowledge they create. I give this lecture in the hopes that all of you will improve it. As more and more people attend this lecture, it doesn't leave any less knowledge. There's no requirement for sharing. True, alternative energy also requires scarce raw materials that we do compete for, but we also recognize that things like knowledge and sunshine are not scarce in the conventional economist sense. So we have to really think about the physical characteristics of the scarce resources we're working with before we can decide how to allocate. We only decide how we allocate, I should say, depends on our answers to the prior questions. What are our goals, and what are the scarce resources required to achieve them, and their physical characteristics? So we often think about, capitalism versus socialism. Capitalism is private ownership of the means of production. Well, maybe that works kind of well for fossil fuels, except for the fact that the costs of fossil fuel use can't be privately owned. They accrue to everybody. But things like knowledge, we might want social ownership of the means of production because it improves through use. For things like sunshine, private ownership is largely impossible. So whether we choose between capitalism or socialism should not be based on ideology, but rather on our decision about what goals we want to achieve and the resources required to achieve them. But there are many more ways of allocating resources besides capitalism and socialism. One is the gift economy. So Food Not Bombs is a group that tries to feed people for free. So the idea of free food. Another is the common ownership, global common shared ownership of resources. There are many different allocation mechanisms, but those can be discussed later. This is just a brief introduction to some of the big questions that emerge, but I want to now turn to another definition of economics that in many ways is more suitable to what we're going to focus on today. And this comes from Polanyi, a noted political economist. And he says the substantive meaning of economic derives from man's dependence for his living upon nature and his fellows. It refers to the interchange with his nature and social environment insofar as this results in supplying him with the means of material want satisfaction. So this says that the economy is about provisioning, meeting our material needs, and to do so, we must interact with each other, with society, and with nature. So within this definition, it basically implies the economy is embedded in society. There is no economy without a social system, and society is embedded in nature. So society depends entirely upon the natural system for all resources and all waste emissions. So we can't separate economy from political and social institutions. It's silly to just discuss the economy rather than the political economy. And really, it's the socio-political economy. It's all interrelated. It's our human system. So this is the classic image in ecological economics of what the economy is like. So the market currently is part of the economy. We have many, many ways of allocating resources. Most of you is, if I ask my students, what has been your biggest type of economic interaction? They always say, oh, the market economy. And I say, oh, really? Your parents charged you for room and board? No, most of our lives, until we're old enough to work on our own, we are part of reciprocity gift economy, which is really the core economy. It's the way we reproduce society. It's the way we train our offspring to fit into our society. And it's mostly done on basis of reciprocity and gifting. So the market is part of a larger economy, not even the most important part. And the economy is embedded within society, which is embedded within the planet. So I want to focus to begin with on the social foundations, human society, which is incredibly important. And what I'm going to present, these aren't like this isn't like necessarily shared by, these ideas aren't necessarily shared by all ecological economists, but I think they're critically important and worth at least considering. So to begin with, I want to introduce the concept of major evolutionary transitions. And the idea is shown in this figure, is that we have lower level organisms that neither cooperate, that don't cooperate, a high potential for conflict, but they can begin to cooperate as a group and eventually transform into a mutually dependent single system, a more complex, higher level organism that cannot serve, where the individual components cannot survive on their own. And a classic example of this is the first forms of life to evolve on our planet were prokaryotes and archaeans. And these were single-celled organisms with no nucleus, and they began to cooperate in ways and eventually merged to become the eukaryote, or the complex cell with a nucleus. And the mitochondria, for example, has a bacterial ancestor. It can no longer survive separate from the cell. Then we developed these complex single cellular organisms that eventually came to merge into multicellular organisms. This was another major evolutionary transition. And your cells cannot survive independently from your body. So we now have a new, more complex, higher organism, which is the multicellular organism. But humans, we are so cooperative, we depend so intensely on each other that none of us is capable of doing everything it takes to survive, we cannot survive separate from our group. If you were denied the ability to interact with others or to share the cultural knowledge we've accumulated over millennia, you couldn't survive a week in almost any ecosystem of the world. We are absolutely dependent on each other to the point where we can think of societies as higher level organisms, that we have to be part of a society to survive. So this is very, very important. This means the fundamental unit of analysis in economics has to be the social system. Individuals can't survive separate from the social system. We have to look at the social organism. So this leads us into the idea of cultural evolution. And evolution by natural selection has three components. First, there needs to be an inheritance mechanism. So typically when people think of evolution, they think of the gene as the inheritance mechanism. My genetic information gets passed down to my offspring, but so does my cultural information. My children speak English because I pass that on to them. They're enculturated in American middle-class culture because that was passed on to them. Their relations with others are largely determined, to the point where variation between individuals within a culture is often much less than variation between cultures, meaning that the variation is now occurring at the level of culture. And so that, the variability I wrote here actually. And there's differential survival between cultures. If you took some Maasai pastoralists and put them in the Arctic with some Inuit, there would clearly be differential survival. If you took some Wall Street executives and put them on the plains with the Maasai, the African savanna, there would also be clearly differential survival. So this means that evolution is acting on the superorganism level of society for individuals. Not strictly though. The more selfish individuals might outcompete other individuals within a group, but the group with the more cooperative individuals will outcompete other groups. So evolution can actually act at the level of the individual or the level of the group in the case of humans. Big question, what binds us together into groups? So we have moral and ethical values, most of which, if you think about them closely, are stating that a moral individual puts the group ahead of the individual, and an immoral person puts the individual ahead of the group. So we have developed moral and ethical values, cultural guidelines that bond us together into a group, which are essential for survival. And these are they vary, moral and ethical values, and even how we use our emotions varies and is passed down to our offspring and leads to differential survivals. So very cooperative groups outcompete other groups. What this also means, though, is that because morals and ethics are key elements of the inheritance mechanism, they are just as scientific as DNA and genes. And as ecological economists, what we are trying to do is develop the moral and ethical values and the accompanying institutions that will allow human society to thrive for the indefinite future in a planet where we don't wipe out the other species. And part of cooperation requires treating people more or less equally. But I want to explore this a little bit more in depth. So what we really need is that the story of human success has been developing, cooperating at larger and larger scales. So we started out as small bands of hunter-gatherers. We developed into larger agricultural band societies. We are now in societies of, countries of 1.4 billion. And this has allowed us, larger groups can tackle larger problems and solve bigger problems, and has increased our survival. So human success has been driven by our ability to cooperate at larger and larger scales. But I do want to distinguish here between cooperation and coercion. Both are ways of coordinating action. Cooperation tends to work well when we have more power, more equality of power. Then we work with each other voluntarily. Coercion occurs when some group gets enough power that it can coerce other groups to act in the interest of the more powerful group. And here, though, even coercion requires cooperation by the coercers. You need cooperation among the elite, among the powerful, to organize and coordinate the force and power they need to make the less powerful act in service of the more powerful. So cooperation is at the heart of human society. And where we are now, as I said, is ecological economists. And I actually want to say one big difference between social sciences and natural sciences. Natural sciences often focus on studying what is. A chemical reaction happens or it doesn't according to certain criteria. Physics, there's certain rules, what is or what isn't. And our theories about physics, chemistry, and biology do not change the system. But social sciences are fundamentally different. Social scientists aren't trying to understand the system as it is per se. Almost every social scientist I've ever met or interacted with or read about is trying to transform the system. They have certain desirable ends they favor and want to understand how to make the system better achieve those ends. So as an ecological economist, I am trying to understand the system not as it is, but as I want it to be. I want to know how to change the system to achieve the goals of a socially just and sustainable future. So I am engaged in intentional evolution. I am trying to change cultural institutions to achieve these goals of social justice and sustainability, which also fundamentally means trying to change our moral and ethical values to redefine the group as not just humanity. I want to redefine the group that we should be cooperating with as all of humanity, but also recognizing that just as a cell can't survive independently of a human body, and a human body can't survive independently of society, the human species can't survive independently of the complex global ecosystem of which we are one part. And so we really need to redefine our goals to include the survival not just of our individual self or individual society, but of humanity as part of this far larger, more encompassing, continually evolving biotic system. So this is kind of, society is incredibly important. We can't look at economics apart from these social foundations. Now I want to turn quickly to the biophysical foundations. This image is taken from the website Rigo Melgar put together and that he sent around to all participants, and from a paper he wrote for Ecological Economics that I encourage people to look at. I'm not going to explain it here, but I do want to talk about the biophysical foundations. The economy is a physical system. It is about real production of real goods and services, and it is subject to the laws of physics. So first of all, the first law of thermodynamics says matter energy can't be created or destroyed, which means we can't make something from nothing. Everything the economy produces requires raw materials that come from our finite planet. The influx of materials from outside our planet is so vanishingly small, we can completely ignore it. We also cannot make something from nothing. Everything we make eventually breaks down, wears out, falls apart, and returns to our environment. It returns to our environment is waste. It's also important, we can't do work without energy. This is definitional, it's tautological, that it takes energy to transform any raw materials from nature into economic products. Economies don't produce things, really. They transform things, and that transformation requires energy. And we have two basic main sources of energy, and one is this endless flow of energy from the sun that strikes the earth at a constant rate over time, and the other is our finite stocks of fossil fuels. There's also uranium and a few other things, but finite stocks of energy on the planet that we can harvest as fast as we wish and as fast as our technology allows. But you can't do any work without energy. And the second law of physics, of thermodynamics, says that entropy always increases in an isolated system. And what it really means, we don't live in an isolated system. We live in what's called a closed system. There is flows of energy coming into the earth, but no flows of material. So we live in a closed system, but the basic principle still applies that all economic activity increases disorder. When we burn a barrel of oil, we don't destroy matter or energy, but we convert that energy into a form that's no longer useful. It's waste heat and waste pollutants. So as we use up these computers and they break down, they no longer function and they become more highly disordered. So our economy basically it's a system for taking raw material from nature, using energy to transform it into economically useful products that give some flux of welfare and well-being to us, but then return to the system as waste. And these are irrefutable laws of physics. We also need to look at the laws of ecology. I'm using the term a little bit loosely here because I'm not defining specific laws. But one thing is that ecosystems are composed of a particular configuration of plants, animals, water, minerals, basically a particular configuration of biotic and abiotic elements that create a system that is self-sustaining, that captures solar energy, that reproduces itself, and also in the process generates all these ecological life support functions, creates the balance of gases in the atmosphere, recycles nutrients, purifies and filters water, creates a stable climate. So intact ecosystems do all of these things. But when the economy captures raw materials from nature, it's removing the structural building blocks of those ecosystems. When we remove the structural building blocks, we degrade the function. We lose those life-sustaining functions provided by our ecosystems. When we also generate waste emissions, both in economic production process. We burn fossil fuels, we create enormous tons of mineral waste, all sorts of waste. And those waste emissions flow back into our ecosystem. We've developed many novel compounds that ecosystems have not developed the capacity to process, and they accumulate in the ecosystem. So we have these waste emissions that flow back into our ecosystem and further degrade ecological function. And we are now well into the domain of overshoot, where we are using up our plants and animals and raw materials so fast that we are sustaining human populations that can't be sustained in the long run at levels of consumption that can't be sustained. And we're doing so by rapidly depleting our forests, our fisheries, our fossil fuel stocks, by depleting all the resources of our planet. But because our planet is so vast, and because our ecosystems were once so rich, we're able to do this for quite a long time before we suffer the consequences. So these are the laws of ecology. And what's happened over the last 100 years, human populations have quadrupled in size. Per capita consumption has increased 9-fold. As the economy has grown, it hasn't grown into a void. It's grown into our finite, complex, and increasingly fragile global ecosystems. So we see here, let's say 100 years ago, if the brown matter represented the economy, we had inflows of matter into the economy and matter flows back out, some of which could be recycled. Energy inflows in, energy flows out that can't be recycled. And the economy generated a flux of economic services that gave humans welfare. And the ecosystems generated a flux of ecosystem services that also added to our welfare. But over the last 100 years, the size of the economy has expanded 36 times, dramatically increasing the flow of economic services to our welfare, but reducing the flow of ecosystem services. And I would like to say that the phrase ecosystem services is somewhat controversial. Some people have defined it as nature's benefits to people. I think that's just a very poor definition, not at all what I mean when I'm using the phrase ecosystem services. When I use the phrase ecosystem services, I distinguish between ecosystem goods. An ecosystem good, I chop down a tree, I convert it into a furniture or a house, I physically transform it into something else at the rate I want. Ecosystem services are radically different. We take those structural building blocks of ecosystems, particular configuration, into an ecosystem that generates a flux of benefits at a rate over time. So for example, the forested watersheds outside of my town, when there's torrential rainstorms, absorb the water in their soils and let it release gradually into the rivers, so they are able to regulate water flows at a rate over time without being physically transformed. The forest is not physically transformed into water regulation, into climate stability, into habitat. It provides those services without being physically transformed in the process. So this is how I distinguish between a good and a service. A good, to use it, you physically transform it into something else. A service has a fund, an ecosystem fund provides a service without being physically transformed in the process. And also ecosystem services, I believe, market services are produced by markets for the benefit of the individual. Public services, we recognize markets cannot provide many types of benefits because they won't provide things that can't be owned, and they're not good at providing things that are not depleted through use. So we rely on the public sector and the civil society to produce these public services. And the phrase public service explicitly means they are not well produced by markets. Ecosystem services, I believe, need to be redefined as nature's benefits to the biotic community of which humans are a part. So we have mechanisms for meeting individual needs and collective human needs, but we lack the institutions for sustaining the complex system of which we are a part and without which we cannot survive. So when I say ecosystem services, I am explicitly defining them as nature's benefits to the biotic community of which we are a part. So I want to talk a little bit now about exponential growth, which is the goal of most economists. They just want the economy to grow on and on forever. And we often hear about the magic of compound interest. If in the year zero, somebody had invested $1 at 5.5% interest compounded annually, it would now be worth a ball of gold the size of the solar system out to the orbit of Pluto at $1,300 an ounce. Obviously that's impossible. But exponential growth, compound interest, is a mathematical phenomena that cannot be matched by nature in the long run. So positive feedback loops, A increases B, increases A, increases B. As our economy grows, a certain percentage increase is based off a bigger base every year, same with compound interest. So we're getting more and more, bigger and bigger annual increments. And that's considered a positive feedback loop, but that cannot be sustained in any natural system. And one feature of exponential growth is constant doubling times. So right now, scientists estimate that half of all plastic ever produced was produced in the last 15 years. And with continuing exponential growth, that means in the next 15 years, we will produce again as much plastic as has ever been produced in all of previous history. So we are going to double the amount of plastic on our planet today, which will therefore be the amount of plastic on our planet 1,000 years from now. We're going to double that in the next 15 years. This is constant doubling times. It also means if we are burning through our fossil fuel reserves, we're increasing our use of fossil fuels by 4% per year, or let's say 3% per year. That would lead to a doubling time of 24 years. that would mean that in the last 24 years, we used half of all oil ever used. Actually, I think it's closer to 30 years because it's a little lower than that 3% growth rate. But it would also mean that in the next 24 years, we'd use that much again, which means that when you're confronting exponential growth, when you're halfway through your resource base, you're only one doubling period away from being all the way through your resource base. So if we did have 3% growth rate in fossil fuel use, the time from half of all fuel being gone to all fuel being gone would be 24 years. Whereas you think, oh, half is left, we've done that in 200 years, no big deal. But with exponential growth, it means we're shockingly close to the end. So I want to turn now also to the big taboo topic, which is I find that I'm attacked from both right and left when I talk about it, which is population growth. And here I want to distinguish between population and consumption. So the problem is not too many people, and it's not too much consumption. It's too many people consuming too much. And this is a very, very important phenomenon. So what we can look at, here's an interesting study by Paul Chakura, I think, who he estimated that 10,000 years ago, before the current era, the biomass of all vertebrates on Earth, of all mammals, I think this was, of all mammals on Earth was, not even all mammals, no, it was all terrestrial animals, was, maybe 250 million tons. But humans now are far larger than that. Humans now, on their own, account for 90% of, basically have 90% of the biomass of all wild animals. If you add together all our domestic livestock, we account for 96% of terrestrial biomass. That means 25 times more humans and their animals than wild animals. So what this means in terms of population, even if humans could graze on grass, we were complete herbivores and had the lowest possible ecological footprint, we would still be consuming 90% of the resources available for all terrestrial animals. That's just too many. But it's much, much, much worse than that. According to my friend and colleague, Nate Higgins, the social metabolism of an individual human, by social metabolism, I mean essentially how much energy, embodied energy we consume and how much waste we put out. And this includes our consumption of all of our, not just our livestock, but also our cars and our airplanes, how many calories we burn. Each human on the planet burns about the same calories as a 30-ton primate. So really, consumption is the elephant in the room. Consumption is what is wildly unsustainable. But population is also unsustainable. So, the current population size. So it's the rich that are the most overpopulated because it is our consumption that is doing the most harm. And the interesting thing when you think about this, my consumption as a rich person is doing harm to the world. I actually live in a very beautiful place, lots of nature around, a beautiful lake right nearby. And, not many people here, but everybody here in my town burns so much fossil fuels that we are changing the global climate. We are wreaking horrible harm to others. So overpopulation in rich countries does harm to the planet. Several of my students are from less rich countries like Colombia, Nepal, Pakistan, Guatemala, various places. And in those countries, overpopulation tends to do more local harm. People aren't burning huge amounts of fossil fuels, but they are polluting their rivers, chopping down their trees. They're doing harm locally. So there's a huge difference between the problems caused by overpopulation, but overpopulation is a problem. So many people have accused me when I talk about overpopulation of blaming the poor. I actually think that addressing the population challenge is empowering the poor. I use as, One prime example, a recent New York Times headline, China's long-term time bomb, falling births stunt population growth. So they're concerned that the population in China is falling. The new term of a demographic crisis is a falling population. And in the article, it says, China relied on an endless stream of young workers willing to toil for low wages to fuel its economic growth. Today, labor costs are rising, in part because of a shortage of workers. The article says this threatens China's economic model, which is based on paying miserable wages to exploited workers. And as soon as you have falling populations, those workers have more power. They can demand higher wages. They can demand more power in society. And this is, if you look through history, when did we, like after the Black Death, when a third of people in Eurasia died, the lower class suddenly became much more powerful. There was abundant land to go around, too few workers, huge redistribution of wealth to the lower income groups. So, my view is failure to talk about the population issue is condemning the poor to continued poverty. And condemning the poor also to the continued impacts of overpopulation in the rich countries. My 2 kids will do as much harm to the planet probably as 50 Indian children. I already spoke about the local versus global impacts. Another concern with overpopulation, people say, well, we're blaming there's no solution. There's nothing we can do about it. That's nonsense. Many countries have taken steps to reduce population growth. We know it can be done. Sometimes the approach has been a little bit too draconian, perhaps, such as in China. But there are, Quebec had a massive decline in population. Brazil had a massive decline in population growth. Iran had a massive decline in population growth. All of these things are achievable, and they're achievable in humanitarian ways. It takes work, but it can be done. So I want to end here. So basically, I've given too brief an introduction to the social and biophysical basis of our economy. But what I want to stress is that the economies are continually evolving systems. They evolve with humans with our genetic evolution. They evolve as human activities change the environment. So humans change the environment, and it must change to adapt to that environment. We started out as small bands of hunter-gatherers with negligible impact on global ecosystems, but we managed, even as small bands of hunter-gatherers, to adapt to every single ecosystem out there that we inhabit today. And this was before we even developed agriculture. When we developed agriculture, we got much denser populations, changed our needed political hierarchies, needed economic hierarchies, property rights, all sorts of things evolved. We then developed an industrial economy. For the first time, we relied on non-renewable resources, fossil fuel powered, vast amounts more production activity, allowing vast increases in the size in human populations and settlements, and hugely negative impacts on global ecosystems. We developed the theories of microeconomics at about the time of the fossil fuel growth. There's no such thing as a capitalist economy without a fossil fuel economy. We entered the Great Depression, showed the gross failure of our current economic model, leading us to develop new institutions, new measurements, new ways of managing the economy. Things like Social Security and unemployment benefits and work guarantees. We now live in a globally interconnected financial economy where money goes around the globe incredibly fast, where the international buying and selling money is about 26 times more takes place than buying and selling of goods and services at the global level. We become globalized financial systems. We have developed an information economy. Information flies around the globe at light speed. It improves through use. All of these things have been major changes in the way our economy functions. The result has been devastation of our global ecosystems. We need to continue to evolve our economy. We need to begin, the problems we now face are social dilemmas. They can't be solved by individual. A social dilemma is when an individual's selfish decisions lead to disaster for society, such as my selfish decision to fly in a plane, spew CO2, causing global climate change. The only solution to these activities, the social dilemmas, is through cooperation. We need to evolve a new ecological economy based on cooperation at a global scale, in which our resource throughput, the rate at which we take material from nature, spew it back into the ecosystems as waste, is well within the carrying capacity of our planet, and we essentially have to adapt or go extinct. And that is the core task right now of ecological economics, to design and carry out a socially just sustainability transition. And I'll leave it here for now, and I will continue with these ideas when I present this coming Friday. Thanks for your attention.